In this video we're going to look at adding and subtracting surds, and probably best just to have a look at the first example and compare it to something else we can already do. So here we've got the 2 root 3's plus 5 root 2's minus root 3. Now the surd part of these, the kind of bit underneath the square root sign, this root 3 and this root 2 and this root 3, we treat them very much the same way as we would treat variables in our algebra simplifications. So if, for instance, instead of what I have here, 2 root 3, I have 2x's. Instead of 5 root 2's, I have 5y's. And instead of root 3, I just have take away x. And if you look there, what I've done is match these up. So the root 3's I've replaced with x's here and here. And the root 2 I've replaced with a y. We'd all be fine simplifying this. We would just say, well, how many x's do I have? And you can see here I've got 2x, take away 1x, which is going to leave me with just 1x. And here, how many y's do I have? Well, I've just got 5 y's. Now, the y's and the x's can't be added together, remember, so we would just keep them as separate. We're collecting like terms. So when we're dealing with surds, we don't collect like terms because we've not got these x's and y's. We collect like surds. So the root 3's are collected with the other root 3, and this root 2 can't be mixed with these ones here. Okay, so let's have a look and go through this one as quick as we can. So first of all, I'm going to have a quick scan of it. I've got root 3's, root 2's and root 3's. So I'm going to simplify the root 3's first. So I've got 2 root 3's here, take away 1 root 3 here, which is going to leave me with just 1 root 3 here. So I'm just going to write that as root 3. I've dealt with these 2 root 3's now, so I'm now going to deal with the root 2. I've got positive 5 of them, so positive 5 root 2 can just go down here, so plus 5 root 2. And what you'll notice is the answer here, x plus 5y, is similar to this one of just root 3 plus 5 root 2's. And that's how we would go about simplifying surds. Now, quite often when this comes up in an exam or a textbook question, you'll tend to find that you have to do a bit of simplification first before you can add or subtract. Looking at part B here, I've got root 18 and 5 root 2. Now, these two bits underneath the square root, they're not the same. But this one here, we can simplify it. So we can use our square number list and kind of go through it, try and find the highest square factor. And when I do simplify that, then I'll need to check again if I have any like surds. So let's start off with this root 18. Now, the list of square numbers, and again, I'll just quickly write them up at the top here. And we'll look for where 18 would sit. 18 would sit between the 16 and the 25 here. So we're going to work down this list. Does this go exactly into root 18? No. Does this go into root 18 exactly? Yes. And now we know it's 9 times 2 to get to 18. So splitting that root 18 into 9 and 2, so it's the square root of 9 and the square root of 2. Remember, the square number goes first. The next one is 5 root 2. Now, we have to ask ourselves, can we actually simplify this root 2? From this list here, the only number that will divide exactly into 2, or that's a factor of 2, is this 1. And division by 1 doesn't really do anything. Anything divided by 1 just stays the same. So it's kind of almost pointless to consider that. So I tend to, when I'm writing that out, I can quite often put a cross across the 1 because I'm not really interested in it. That means that this is already in its simplest form, so I can just drop that down a line. So it's 5 root 2 on the next line as well. Now we put the square number here at the front, remember, because the square root of 9 we can do. The square root of 9 is 3, and the root 2 we can't do, so it remains as root 2. And then again, we're going to drop that down another line. Now at the start, I had 2 different roots. I had root 18 and root 2, so I couldn't collect together like surds. Whereas now I have root 2 and another root 2, so I can gather these together. Here I have 3 lots of root 2. I'm adding on 5 lots of root 2, so 3 lots of something plus 5 lots of something gives me 8 lots of that thing, so 8 lots of root 2. And that is then fully simplified. We'll now just quickly look at a further 2 examples. And again here, at the moment, when we tried to add these 2 together, we can't collect together like surds because this is root 32 and this is root 18. So it's like having x plus y. We can't do anything with it. So what I'm going to do is I'm going to try and simplify both of these this time. So let's start off with root 32. And again, I'm going to put my square numbers along the top. And we'll start looking at the first one here. Root 32. Root 32 would sit about here in my square numbers. So does 25 go exactly in? No. Does 16? Yes. And 16 times 2 makes 32. So I'm going to split that into a 16 and a 2. So remember, both parts should be under a square root. So root 16, root 2. And I'm going to keep going across to the next one. And I'll come back to the next line of this in a minute. Square root of 18, well, that sits about there. So does 16 go exactly in? No. And does 9 go exactly in? The answer is yes. It's 9 times 2 makes 18. So I can then again split that into plus root 9, root 2. And again, that's my 9 2's make up my 18 here. Okay, once I've done that, again, you'll notice in both cases, here and here, I've put the square number first because I can actually find the square root of it. So the square root of 16 is 4, so that becomes 4 lots of root 2. We can't do the root 2, remember, plus, and then again, we can do the square root of 9. We can't do the square root of root 2. So the square root of 9 is 3, but the root 2 has to stay as it is. And then once again, what you can see here, where I didn't have like surds up here, I do now. These are both root 2s. So I've got 4 root 2s plus 3 root 2s. So I have in total there 7 root 2s. Now we'll finish off on quite a hard example. Lots of things going on in this one. So I've got 6 times root 54 plus root 75 minus root 24 plus 3 root 48. So we're just going to begin at the beginning and we're going to be really systematic as we go through it. So this is 6 times root 54. So let's look at the root 54 part first. It would sit up here. So start going down looking for a number that will go into 54 exactly. That's a no, 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 and no, and yes for that one. So 9 times 6 is 54. So we're going to change that root 54 to root 9, root 6. Now it's already got a 6 out the front here, so that's going to go in first. And then the root 54 is going to be the square root of 9 times the square root of 6. And then we'll move on to the next one. We'll keep coming back to each line as we go. So root 75, again 75 sits here. So what number goes exactly into 75 from this list? We're looking for the highest ones. We're starting at the top of the list and working down. No, 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 yes. Okay, so 25 times 3 gives us our 75, so we're going to write that as root 25 times root 3, and that's my root 75 there. And again, I'm putting the square number first. We're now on to this minus root 24, so let's put the minus in first, and then find 24, or where roughly it would be. It would be about here, and work down. Does this go exactly into 24? No. Does this? No. Does this? And the answer is yes. That's usually 4 times 6, well not usually, always 4 times 6 is 24, so 4 times 6, that's going to become root 4, root 6. And remember that 4 times the 6 is this 24 here. The last one has plus 3 times root 48. So that's plus 3 times, and then you'll notice the pattern here. We're getting 2 roots from this root 48. So 48 sits about there. And again, same process. Does that go into 48 exactly? No, no, yes. Okay, 16 times 3 is 48. So that's 16, root 16 first, and then the 3 after it. And then what we're going to do is we're going to start at the beginning of that line again, and we're going to actually find the square root of all of the square numbers there. So remember, we put the square numbers in each case at the front. So the root 9, the root 25, the root 4, and the root 16. So it'll be nice and easy to hopefully do them. So we're going to leave that as 6 times. The square root of 9 is 3, and the root 6 is a surd. It's going to stay as it is. Plus the square root of 25 is 5, and the root 3 again is going to stay as it is. Minus root 4, which is 2, and root 6, again we can't do that, so we're just going to leave it as root 6. And then that's 3 times the root 16 is just 4, and that's 4 lots of root 3. Now before I go any further with this and start collecting terms together, I want to tidy this up a little bit. So this 6 times 3 here, and this 3 times 4 here. I'm just going to take my time, run through this next line and tidy that up. So 6 3s are 18, so it's 18 root 6s, plus 5 root 3s, minus 2 root 6s, plus 12 root 3s. Now if you look at this, what I've got is I have, again, 2 different types of surd there. Okay, so I've got root 6s here and here, and separate to that I've got these root 3s here and here. So it's like collecting like terms in algebra. We collect our x's, we collect our y's. Here I'm going to collect my root 6s, and then I'm going to collect my root 3s. So let's look at the green ones first. Root 6, so 18 root 6s, take away 2 root 6s. So 18 take away 2 is 16. That means I've got 16 root 6s. And then I'm going to look at the blue ones. That's my root 3s, 5 root 3s, plus 12 root 3s. And that's going to give me a total of positive 17 root 3s. And then that's fully simplified. Now, if you like, what you can do now is you can pause the video here, try this question, and then press play to check you can now do this. Okay, so pause the video now, and we'll go over it in a second. Right, hopefully you've tried this, and we're going to go through it step by step. At the top here, we are going to just quickly write out our square numbers, and we'll start with the root 63 here. Now, root 63 is about here, so which of these go exactly into root 63? So 49 doesn't, 36 doesn't, 25 doesn't, 16 doesn't, 9 does. That's 9 times 7 there, so that can become root 9, root 7. So again, square number goes first. Now this one plus 2 root 3s. The root 3 is the bit that I could potentially simplify, but if you look at this, the only number below where 3 would sit is 1, and dividing by 1 doesn't do anything. We generally ignore that one, so that's already in simplest form. So that's going to become, or stay I should say, 2 root 3. The next one, root 28, again it sits about here, so go down your list. That doesn't go into 28, neither does that, neither does that. But 4 does go into 28, and it goes in 7 times. So it's 4 times 7 is 28. So that's root 4, root 7 instead of root 28. And again, now what we're going to do is take the square root of the square numbers here and here. So square root of 9 is 3, and that's going to stay as root 7. Then I've got this 2 lots of root 3, that again, we can't do anything more with that. And the square root of 4 is 2, so that's minus 2 lots of root 7. Now, if we go through this, we can collect our like terms. So I've got root 7s here and here, and we'll use a different colour to highlight our root 3 there. And we'll now just gather together our terms. So root 7s, I've got 3 lots of root 7, and it's take away 2 lots of root 7, which is 1 lot of root 7. And then here, that's the root 7s done, so they've been simplified to 1 lot of root 7, and now I've just got 2 root 3s left over, so plus 2 root 3s. And that's it fully simplified.